Hi Amanda, my presentation is about ancient Egyptian numerology, and I will be discussing their number system as well as how they add, subtract, multiply, and divide. Ancient Egypt was a civilization that existed from 3100 BC to 3100 to 2686 BC. They were the first to develop the base 10 numeration system, but they did not have zero. Their numbers are hieroglyphic symbols, and the numbers are written and read from right to left. So the number 3526 is written as 3 lotus flowers, 5 rope coils, 6 heel bones, and 2 staffs. And this is the opposite of how we read and write, so it's kind of hard to get used to. The types of people that would be using the simplest types of mathematics, which I focused on in this presentation, were shopkeepers, cooks, and lower classes. Higher mathematics were used by priests and priestesses who were in charge of workers and builders. But since most people only use basic math, I will be discussing the math they and we use in everyday life. So these images show the many symbols that were used as numerals. So numbers 1 through 9 were represented with the staff, and then multiples of 10 up to 100 are represented by the heel bone, and so on in multiples of 10. In the next few slides, I will show you how these symbols are added, subtracted, multiplied, and divided, and how each function changes how the numerals were written and arranged. So for addition, you just add up and down, like adding two numbers. So these show what 456 plus 265 looks like. So the way we add, it can either be 456 plus 265 in one line with the answer right next to it, or it could be 465 plus 265 with the numbers stacked and the answer below, and this is how the Egyptians did it. So in the example, the two numbers are hieroglyphically represented, and the numerals are then combined into one group. From there, the two staves become one staff. So from there, everything is combined into one line, and then because there are 10 staves, it becomes a heel bone, and there's only one staff remaining, and then the heel bones are combined into two. They become the two coils. They add to the coils, and so then two heel bones are left, and with the 7 coils, which means that 721 is the answer. So you just add them all together and condense them based on their multiples. And subtraction is pretty similar to how we subtract and borrow. So in the top box, it shows what 456 minus 265 would look like. So that's them written out on the top box. And then in the bottom box, it shows that because you're subtracting 6 tens from 5 tens, you have to borrow from the hundreds, giving you 15 heel bones and 1 less coil. And then now you can subtract evenly. So that would be 3 heel bones minus 2 heel bones is 1. And then the 15 minus 5 would be 9. So 15 minus 6, would be the 9 heel bones. And then because there are no more staffs left, that would be, or there's 1 less staff, that would be the 191 that you see there. So you just make sure that everything is equal or of greater value in the top, and then you can subtract normally. For multiplication, we would normally write 25 or 29 over 5 with the 5 under the 9 and cross multiply, but the Egyptians used the distributive property of multiplication and multiplying columns. On the left, the numbers start at 1 and double until the number is 1 less than 5. And then the coordinating numbers on the right are the other number in the equation. So 5 times 29. So you start at 29 and then it doubles each time. And then once the number on the left equals 1, so 1 plus 4 equals 5. So once that equals 5, and then once the other side is at 5 too, you add the first number plus the last number to get the answer. So of what 140 or 5 times 29 would be, which is 145. And then for division, it's done much the same way as multiplication, but is very different from our system. So to find 98 divided by 7, they use the column system to find how many times 7 goes into 98 through multiples. The numbers on the left add up to 14, which is what 98 divided by 7 is, and the numbers on the right end up adding to 98. So on the left, you do the numbers that, so 14, 28, and 56 all add up to 98, and then those corresponding numbers on the left add up to 14, which is 98 divided by 7. And then for 0 in numerals, the ancient Egyptians did not have a symbol for 0, since it was conceptually irrelevant in their number system. The concept of 0 was independently invented by the Indians and the Mayans in the 3rd century AD, and 0 did not reach Europe until after 800 AD. And so then for my examples of addition, the top box shows 2 separate examples, and you just add. So the first one, you can just add normally from top to bottom. So that equals 1,644. But then in the top box, but the bottom example, since there are 10 coils that you have to add together, as well as 10 heel bones, that has to become one lotus flower for thousands, and then the heel bones become 1 coil for hundreds, and then since the staffs are under 10, they just stay independent. So that equals 1,108. And then the bottom 2 boxes show a subtraction problem. So in the middle box, it shows that we are subtracting 5 coils from 4 coils. So because we can't do that, we have to borrow from the top 3,000s or 3 lotus flowers, and that becomes, in the bottom box, 14 coils first, because you add the 10, and then you can subtract normally because there are more on top than on the bottom, and that equals 902. And then for my multiplication example, there are 2 separate multiplication examples in the top. So since 1 plus 3 equals 4, and since we're trying to find the answer to 4 times 20, you look at what 1 corresponds to and then what 3 corresponds to, and you add those together to get 80, which is 4 times 20. And then for the second example, you look at what is in the ones place, which is 19, and what is in 5, which is 95. And since 1 plus 5 equals 6, that means that 19 plus 95 is 114, so that is what 6 times 19 would be. And then for the division problem, I'm dividing 112 by 7. To find this, the column system is used again. The left column goes to 8, and then the right-hand column goes up in multiples of 7, because you're trying to find how many times 7 goes into 12, or 112. So once you find the numerals that add up to 112 on the right, the corresponding numbers on the left are what 112 divided by 7 is, which equals 16. And then here are my sources. Thank you for listening to my video.